Alright, so setting up and solving differential equations. This is part 4, and it's the first time you're really going to have to do any kind of heavy lifting in terms of integration and so on. Now the question is, you can read through it. The rate of growth of a town's population, n, is 5% of its population at any time t years. So the rate of growth of a town's population. So that's going to be the change in population, which they're going to say is n, with respect to time, and time is in years, is 5% of its population. 0.05 of its population. So even though they don't use the word directly proportional there, it does state that they're directly linked. The rate of growth of a town's population is 5% of its population at any time t years. If its population is currently 100,000 people at time 0, find the population at any time t, or the population in 3 years. So if we want to find the population at any time t, we're going to have to come up with we're going to have to solve an equation here. So step 1 is obviously to write our differential equation. Now the obvious problem that you guys can all handle now is that there's an n on the top, there's an n on the top. So we can't sort of integrate directly, so we're going to have to take the inverse of. So we have dt dn equals 1 on 0.05 n, and we can probably just simplify the right hand side here by moving everything to the not by moving everything to the top, but by multiplying by 20 top and bottom, just so we get rid of the 0.05. So now we know that the change in t with respect to n is 20 on n. But if we integrate this, then we'll just know what t is. So in integral notation, we have t equals the integral of 20 on n with respect to n plus c. And we should be able to integrate that fairly easily. You're just going to end up with a log of some sort. 20 log base e an. Now that an has come into there because of that c value. Because c equals log base e a, which is so we can just sort of put that back in. And we have done something like that before, where that c gets put into the log base e an, just simplifies our equation. We've got some initial condition here. The initial condition given at the start was if its population is currently 100,000 people at time 0, we can let time 0 here, and we can sub 100,000 in for n. And as in a previous video we stated, that's going to make our life really easy, because when t equals 0, 0 equals 20 times log base e 100,000 a. We can divide by 20. 0 divided by 20 is going to be 0. That's going to leave us with log base e 100,000 a. That means that 100,000 a equals 1, because the only way that log base e to the something can equal 0 is if the something is equal to 1. That's one of your log laws. I'll just write it down real quick. That's the log law I'm referring to. And then solving for a, and obviously that's going to be like 1 over 100,000. So now we have a proper equation for t, not an equation with a constant a, but our equation is actually t equals 20 log base e over log base e n over 100,000. And then you can rearrange that into like an exponential function, or you can make n the subject, is probably the better way to think of it. Okay, so now we have n equals 100,000 e to the power of 0.05, not c, t. And there's our equation that you can see there. Okay, I might just need to scroll up to our original question, which says, find the population at time t. Well, there we have it. N equals 100,000 e to the power of 0.05 t. And then the population in 3 years. Well, look, that's really easy. Sub t equals 3 in, and we have 116,183 people in 3 years. All right, so there's nothing there that you haven't done before. You might be just a tiny bit rusty on going from there to there. Come and talk to me about that if you're having some trouble there. But apart from that, all the rest of it should be fairly straightforward.